Imagine a world where metals burst into flames when touched by water, where ordinary liquids shift colors like a living rainbow, and where substances transform in ways that defy our expectations. Picture dropping a small metal into a glass of water, only to see it explode in a burst of fire. Chemistry is full of mysteries, and some reactions are so bizarre they seem like magic. But behind these strange transformations are real scientific principles, forces of nature waiting to be discovered. Some of the strangest chemical reactions in existence are not only captivating to watch, but also unlock the secrets of how the world works at a molecular level. One of the most shocking chemical reactions occurs when sodium meets water. Sodium is a soft, silvery metal that you can cut with a knife, but despite its harmless appearance, it is highly reactive. Drop a small piece into water, and it instantly sizzles and darts across the surface before exploding into bright orange flames. The reason for this violent display lies in sodium's tendency to lose electrons easily, creating a rapid release of energy. When it comes into contact with water, it reacts to form sodium hydroxide and hydrogen gas. The reaction releases so much heat that the hydrogen ignites, creating a small fireball. If a larger piece of sodium is used, the explosion can be far more intense, making this reaction one of the most dangerous yet fascinating demonstrations in chemistry. But sodium isn't the only element that reacts this way. Its cousin, cesium, takes the reaction to an entirely new level. Cesium is even more reactive than sodium, and if dropped into water, it doesn't just sizzle, it detonates instantly. The extreme reactivity of cesium means that even a small amount can cause an enormous explosion, making it one of the most dangerous alkali metals known to science. The ability of alkali metals to react so violently with water is due to their position on the periodic table, where elements in the first column have a strong tendency to lose electrons and form highly reactive ions. Equally mesmerizing but much less dangerous is the Belousov-Zhabotinsky reaction, a chemical process that appears almost alive. Unlike most reactions, which proceed in a single direction until they reach completion, this one oscillates, continuously shifting colors between red, blue, and yellow in a mesmerizing loop. The reason behind this strange behavior is the presence of feedback loops in the reaction. As one set of chemicals is consumed, another set forms and then reverts back, creating a rhythmic, self-sustaining cycle. This reaction is not only visually stunning, but also helps scientists understand biological rhythms, including the beating of the human heart and the way chemical signals travel through the brain. Another mind-boggling reaction is the Briggs-Rauscher reaction, which behaves like a chemical clock. When certain chemicals are mixed together, the solution cycles through different colors, clear, amber, and deep blue, over and over again. This oscillation happens because two competing reactions are occurring at the same time. One reaction tries to move the system in one direction, while the other pushes it back. As a result, the colors flip back and forth in a repeating cycle. This phenomenon is a powerful example of how chemistry can create order out of chaos, revealing hidden patterns in what might seem like random reactions. Some of the most bizarre reactions in chemistry involve substances that explode with almost no warning. One of the most notorious examples is nitrogen triiodide, a compound so unstable that even the slightest touch can cause it to detonate. Nitrogen triiodide starts as a harmless-looking purple powder, but once it dries, even the lightest tap can trigger an explosive reaction. The reason for this instability lies in the structure of the nitrogen and iodine atoms. The bonds between them are weak and store a large amount of energy, making the compound extremely sensitive to disturbance. Because of its unpredictable nature, nitrogen triiodide is rarely used outside of controlled demonstrations, but it remains one of the most dramatic examples of how chemistry can unleash enormous energy in an instant. Some chemical reactions seem almost magical, because they allow us to see normally invisible forces at work. Supercooled water is a fascinating example. Normally, water freezes at 0 degrees, but under certain conditions, it can be cooled far below that temperature while remaining liquid. This happens when the water is very pure and undisturbed, preventing ice crystals from forming. However, the moment the supercooled water is disturbed, by shaking the container or introducing a small particle, it freezes instantly. This rapid transformation from liquid to solid is an incredible display of how delicate molecular structures can be disrupted by the tiniest change. One of the strangest decomposition reactions in chemistry involves mercury defy thiocyanate. When ignited, this seemingly ordinary white powder erupts into a mass of dark, snake-like tendrils that twist and writhe as they expand. The eerie, organic-looking structures form due to the rapid release of gases and the rearrangement of solid material, creating an effect that looks almost alive. Scientists have used this reaction to study how gases interact with solid structures, and while it was once used in early pyrotechnic displays, known as Pharaoh's serpents, its toxic byproducts have led to its decline in modern demonstrations. Still, the visual effect is nothing short of haunting. When a small pile of the white powder is ignited, dark, writhing tendrils begin to emerge, twisting and curling as if alive. These eerie, snake-like formations expand rapidly, creating a mesmerizing, almost hypnotic display. The reaction is so bizarre and unsettling that it seems to defy logic, offering a rare glimpse into the strange and unpredictable nature of chemical transformations. Another visually stunning reaction is chemiluminescence, the process by which certain chemicals emit light when they react. One of the most famous examples is the reaction between luminol and hydrogen peroxide. When these substances mix, they produce a ghostly blue glow. This happens because the reaction releases energy in the form of light instead of heat. Chemiluminescence is used in forensic science to detect blood at crime scenes, as even trace amounts of iron in blood can trigger the glowing reaction. This principle is also found in nature, powering the bioluminescence of fireflies and deep-sea creatures that light up the ocean depths. Some chemical reactions involve substances that defy our expectations of how materials should behave. One of the strangest is the Leidenfrost effect, which occurs when a liquid, such as water, is dropped onto a surface much hotter than its boiling point. Instead of immediately evaporating, the water droplets hover above the surface, floating on a thin layer of steam. This creates the illusion that the droplets are magically repelled from the surface, when in reality, they are cushioned by the insulating layer of vapor. This effect allows water droplets to move unpredictably, sometimes even climbing uphill, and is a perfect example of how heat can influence the physical properties of a substance in unexpected ways. One of the most famous and explosive reactions in chemistry is the thermite reaction. This reaction occurs when a mixture of aluminum powder and iron oxide is ignited, producing an intense burst of heat and molten iron. The thermite reaction is so powerful that it has been used in welding and even in military applications to destroy equipment beyond repair. The extreme heat generated, over 2,500 degrees, is enough to melt through steel in seconds. The reason for this immense energy release is the transfer of oxygen from the iron oxide to the aluminum, a process that releases a huge amount of heat in an instant. Chemistry is full of surprises, and the strangest chemical reactions remind us that the world is governed by invisible forces that can produce astonishing effects. From explosive metals and oscillating colors to glowing liquids and instant ice, these reactions challenge our understanding and inspire curiosity. They show us that science is not just about facts and formulas. It's a journey into the unknown, where even the most ordinary substances can behave in extraordinary ways. The next time you see a chemical reaction unfold, ask yourself, what hidden forces are at work? The answers might just change the way you see the world.